There are about 800,000 asteroids orbiting the Sun at high speed. They're pieces of rock of varying sizes left over from the formation of planetary systems. Seems like nothing interesting. However, asteroids are regularly blowing up the internet. Celestial rocks plan to collide with the Earth and destroy our world. Almost every week, there are reports of an asteroid the size of a bus, a vending machine, half or even an entire giraffe heading our way. They have been known as the killers of cities and planets, the gods of chaos, and the rocks of Armageddon. One of the most notorious stories involved an asteroid that looked like a human skull. It approached Earth just in time for Halloween. Many took such mystical coincidences as an ominous omen. Global catastrophe seemed inevitable. Indeed, the terrifying skull flew 490,000 kilometers to Earth and 150,000 kilometers from the Moon. And all the buses, giraffes, and chaos gods are safely on their way. But of course, the dangers posed by asteroids are real. In the history of our planet, there are known examples of catastrophic collisions with celestial rocks. To prevent such a thing from happening again, astronomers are looking for and studying the most dangerous steroids. Let's take a look at this arsenal of celestial weapons that nature can use against us. What threatens Earth with a celestial rock, with a strange cross that looks like a Varan? Can fantastic mirror bees save us from disaster? What asteroid, instead of an enemy, will become a real Klondike for space travelers? Before we find out, let us marvel once again at the majesty. Drinks the night sky. If we're lucky, we'll see a shooting star. That means another small piece of meteorite burned up on re-entry into the atmosphere. The chances of seeing this light show are very high. According to NASA, about 48.5 tons of meteorites fall to Earth every day. Traditionally, when you see any of them, you should close your eyes and make a wish. But if the star gets bigger and bigger and turns into a ball of fire, it's better to think about safety. There could be a deadly asteroid in the Earth's atmosphere. Fear not. The probability of such a scenario is extremely low. A celestial body, the size of an automobile. According to the International Institute of Planetary Sciences, it collides with our planet once a year. Reaching a city square, it can destroy buildings and break windows in neighboring houses. Not so tragic. According to scientists, truly dangerous large asteroids visit us no more often than once every 2,000 years. That's a huge time frame, but it doesn't rule out the possibility that one of the giants might decide to join us now. When you watch this video, what's happening to us and to Earth is partly explained by the planet's past. In February 2013, a spectacular fire ignited in the winter sky near the city of Chelyabinsk in southeastern Russia. Closer to the Earth's surface, it erupted, reflecting millions of lights off the snow, and then exploded 30 miles high, encasing it in a momentary flash of sunlight. The blast wave released 10 times more energy than the atomic bomb dropped on Hiroshima. It shattered the windows of thousands of buildings and destroyed the roofs of homes. More than 1,400 people were injured. It is, you might say, still happy. Chelyabinsk asteroid the size of a tennis court moved at a fairly large angle. That is, it exploded quite high above the surface of the planet. But getting out of its trajectory would have done far more damage. A century ago, a more dangerous celestial project. In 1908, an asteroid 50 to 60 meters wide, about the size of an Olympic swimming pool, exploded over eastern Siberia, near the Tunguska River. 80 million trees were destroyed, over 2,150 square kilometers. Eyewitnesses recalled that the crazy explosion caused violent tremors, and the shock wave threw people high into the air. The asteroid, known as the Tunguska meteorite, was twice as wide as Chelyabinsk, but 10 times more massive. As a result, the explosion released a lot of energy into the atmosphere. The area was virtually uninhabited, so damage and injuries were minimal. However, if something like this had happened over a large city, things would have been tragic. Astronomers have created an online tool that allows them to study the impacts of asteroids around the world. It takes into account the size of the rock, the material and its properties, the speed and height of the explosion. The angle at which a celestial block enters the atmosphere is also irrelevant. At a lower angle, the asteroid will take longer to travel through the atmosphere and dissipate some of its energy. An impact perpendicular to the surface will have a more devastating effect. An online model shows that if an asteroid the size of the Tunguska meteorite were to hit, for example, the center of London, even the remotest suburbs would be affected. Although the metropolis would not be completely destroyed, however, if a denser metallic asteroid falls, rather than a rocky one like Tunguska, the damage will be much more severe. In that case, London could disappear from the face of the Earth. Scientists' models show what the consequences would be if large asteroids collided with megaliths. 100 meters. If the size of a soccer field reaches the city, the situation will be even worse. Other parameters would form a crater. The explosion will destroy a building 15 kilometers away and blow out windows in a radius of 100 kilometers. Seismic tremors will be generated around the disaster site and spread further away from the epicenter. Debris thrown into the air by the force of the impact will be thrown back within a few kilometers, and the fine dust and dirt in the air will be suspended before the wind carries it farther away. When the asteroid collides with Earth, there will be flares. All of this will inevitably result in human casualties. 150 meters. If an asteroid 150 meters in diameter were the size of a soccer stadium, the results would be worse. The crater created by the impact would be over 1.6 kilometers wide and 370 meters deep. If it reached the center of London, windows would be shattered in southeast England. But worst of all, the deadly force of the impact in the center of the metropolis, everyone will die from the blast wave. Even a larger rock, 800 meters in diameter, the size of a sports stadium, could be truly devastating. Such an asteroid would form a crater more than 11 kilometers in diameter and more than 600 meters deep. A destructive tremor of 7.4 on the Richter scale would be felt up to 500 miles from the impact site. The blast wave will break more than 1,500 windows. If the epicenter of events is London, windows of buildings in France and the Netherlands will also be left without glass. But what is particularly frightening is the inevitability of hundreds of thousands of casualties in this scenario. Fortunately, the likelihood of a space rock hitting a populated area is extremely low. 70% of the Earth is covered by oceans, and it is likely that a projectile from the sky will end up in its waters. If it sinks somewhere deep, there will be no consequences for us. However, if it lands in slippery water, a large destructive tsunami would engulf the coastline. The asteroid would have to be much bigger to end the world. And we know that such a bitter experience has already happened in the history of our planet. Sure, we're talking about the huge celestial rock that wiped out the dinosaurs 66 million years ago. But at the same time, there are 80% of other kinds of creatures that somehow very often come to mind. From the very beginning, the giant was ready for a crazy impact. A block 12 kilometers in diameter and weighing several trillion tons flew into the planet's atmosphere at the most devastating angle. The Earth's gravity attracted it even more strongly, accelerating it to 20 kilometers per second. The asteroid, like a piston, flattened a 20-kilometer column of air every second, one by one, tighter and tighter. This process, along with the friction, heated the celestial body to tens of thousands of degrees. Everything around it was several times brighter than the sun. The asteroid fell into the Gulf of Mexico off the northern coast of the Mexican peninsula. The energy released during the formation of the crater was equivalent to the impact of 10 billion atomic bombs on Hiroshima. In 1 second, the asteroid pierced the Earth's crust, forming a crater 180 kilometers wide and 20 kilometers deep. During the impact, the entire globe rang like 1,000 bells. When the Krakatau volcano erupted 70 miles from Indonesia, half the crew of one ship had their ears blown off. The explosion was 1,000,000 times stronger than when the asteroid fell. Immediately, shock waves rushed in all directions at speeds faster than the speed of sound. Even hundreds of kilometers from the crater, they lifted animals with live skins into the air. The heaviest dinosaurs flew like balloons. Passing through the atmosphere, the glowing asteroid caused large-scale fires. In addition, the impact sent 15 trillion tons of rock into the sky. A small portion of it was sent into space. The rest, including one the size of a house, began falling from orbit. At the same time, glassy showers of spherulites, 5-millimeter diameter balls of glowing rock, poured from the sky. The rock storms and boiling glass showers killed countless animals. After that, a huge tsunami 100 meters high rose from the ocean. To get an idea of its scale, consider the 2011 tsunami in Japan. Then, the height of the waves reached 10 meters. Despite this, almost the entire island state was destroyed, and the giant water structure due to the impact of an asteroid penetrated thousands of kilometers. The explosion also triggered a series of earthquakes, with a magnitude of up to 11.2. The tremors were about 50 times stronger than any earthquake we know of. The planet was so shaken that all the volcanoes woke up and began to erupt. Soon, the Earth was flooded with acid rain as hundreds of billions of tons of sulfur compounds were dumped into the troposphere among other rocks. Within weeks, sulfuric acid rained from the sky all over the planet. It poisoned the soil and water bodies, killing countless marine animals as well as the inhabitants of shallow waters, oceans, lakes, and rivers. After the volcano erupted, a dense blanket of dust, ash, and dust covered our world, blocking out light and heat. Even at noon, it was as dark as a moonlit night. The temperature dropped to 28 degrees. It was atomic winter. Only fungi and mold thrived in such conditions, ate rotten food. The animals were deprived of water and food. The ground, strewn with corpses, must have been a frightening sight at the time. It is frightening to think how many billions of people and animals on our presently inhabited planet could be destroyed by such an asteroid. According to scientists, it does not pose a threat to us in the near future. However, astronomers do not exclude the descent of less giant, but very dangerous celestial killers. Based on data from the WISE Space Telescope, NASA identified 4,700 potential celestial bodies with a diameter of more than 100 meters. The biggest risk factors were also identified. Here are the top 5 space rocks that could cause a real carnage in our world. 5th place, Semi-Board. It just opens up the top, but astronomers consider the 1979 HB very slim. This asteroid, measuring 660 meters and weighing 390 million tons, was discovered in 1979. After a few years, it disappeared from telescopes and has not been found. Therefore, the orbit of 1979 XB is poorly understood. Who knows where and when it will become popular and what surprises it may bring? Astronomers have determined that the probability that 1979 HB21 will collide with Earth on December 14, 2011-13 is only 1 in 1.8 million. However, the consequences would be devastating. The collision of a large asteroid with Earth would release energy equivalent to the explosion of 30 billion tons of TNT. Then, there would be no escape from global catastrophe on the planet. Our next asteroid is 2007 FT3. It is also considered lost and therefore particularly dangerous to Earth. Astronomers discovered the asteroid in 2007 and stopped seeing it the same year. However, during this short period, scientists discovered that 2007 FT3 orbits the Sun in 1.2 years. Its maximum distance from the star is 221 million kilometers, and its maximum distance from the star is 117 million kilometers. Meanwhile, the asteroid is moving at a speed of 24.8 kilometers per second. The exact size of the celestial body is unknown, but according to calculations, it is a real giant. Its width is probably between 266 and 594 meters, and its mass is 55 million tons. This block may collide with the Earth very soon, in 2024 or 2030. The probability of collision is estimated at 1 in 10 million. If 2007 Feet 3 were to hit Earth, it would release energy equivalent to the explosion of 2.6 billion tons of TNT. That's enough to cause us a lot of regional damage. But there would be no large-scale cataclysm. One of the last asteroids in the upper middle is 2023 TL4, which astronomers saw in 2023. It immediately found itself in a particularly dangerous situation. It's a small near-Earth asteroid 330 meters in diameter and 47 million tons in mass. It has a very rare, very long orbit. So while traveling around the Sun, the asteroid passes not only the orbit of Earth, but also Mars. Based on observations of the period from October 8th to October 19th, 2023, astronomers have calculated the possibility of 2023 TL4 colliding with our planet. This is 1 in 181,000, and the date of impact is October 10th, 2119. In the event of an impact in 2023, TL4 would release energy equivalent to 7.5 billion tons of TNT. In this case, entire cities and regions would be destroyed. Second place, 1950. Yes, scientists discovered this celestial rock in 1950, then lost sight of it for nearly half a century. When it reappeared in telescopes, astronomers were able to study 1950 DA in detail. It is a large celestial body with a diameter of 1.3 kilometers and a mass of 76 million tons. The asteroid has a structure consisting of various celestial bodies containing iron and nickel. And the kinetic force of the impact of metallic asteroids is enormous. According to asteroid calculations, a collision with Earth is possible on March 16, 2880, from 1950. The probability of the event is quite high, at 1 in 3,400. We will keep our fingers crossed for posterity that this does not happen. Otherwise, the event will result in a release equivalent to 75 billion tons of TNT. This would cause a global catastrophe that would radically alter the climate and even wipe out humanity. Topping the list is near-Earth asteroid 101-955, or Bennu, discovered in September 1999. It is a huge space project with a diameter of half a kilometer and weighing 74 million tons. It travels through space at a very high speed, making a revolution around the Sun every 6 years on Earth. Bennu probably comes from the inner part of an asteroid belt full of similar rocks. However, it's not just a piece of rock. The Osiris-Rex NASA spacecraft visited the asteroid and took some beautiful photos of the terrifying celestial body. Along the equator of Bennu, is an amazing hump-shaped outgrowth. It consists of fine-grained particles of pulverized rock, regolith. It is possible that the particles accumulate in one place and form a mountain because of the low drag and rapid rotation of the steroid. But that's not the main focus of the celestial rock. With any luck, space travelers will be able to see Bennu's spectacular fireworks display. These won't be the only bright and colorful skylights. The asteroid is kicking up dust and rocks up to 10 centimeters in size. Scientists believe these jets may be relieving heat stress, releasing water vapor, or exposed to meteorites. Bennu is considered the most dangerous to our planet, but thankfully, not in the near future. NASA estimates that the asteroid will approach Earth on September 24, 2182. The probability of its collision with our planet is 1 in 2,700 years. In this case, the impact energy will be equivalent to the explosion of 1.4 billion tons of TNT. A smart explosion would cause massive regional destruction. If released into a populated area, it could kill millions of people. But it would not lead to global destruction of the planet. NASA has sent the OSIRIS-REx spacecraft to study the asteroid in detail. Scientists hope not only to better understand its potential threat, but also to learn the secrets of our world's youth. Bennu is a very old asteroid. The material obtained dates back at least 4.5 billion years ago. That is, its formation occurred at the same time as the birth of the solar system. In October 2020, OSIRIS-REx began collecting material from asteroids. The surface of the celestial body turned out to be amazing, so to penetrate deep into it, the study was not possible. In September 2023, the device returned to Earth and dropped a capsule the size of a mini-fridge containing 250 grams of rock and dust from the asteroid. Scientists immediately began studying the samples. At the same time, the OSIRIS-REx spacecraft was launched into our impenetrable rocket. However, without it, the journey to the most dangerous asteroids would be incomplete. We are talking about the relatively small Apophis, 340 meters wide and weighing 27 million tons. Not so long ago, it was a real internet star. Discovered in 2001, Apophis has topped the list of the most dangerous asteroids for 2 decades. From time to time, real panic follows the news of its imminent landfall. In 2021, the asteroid's monstrous fame suddenly faded. Then Apophis flew at a distance of 17 million kilometers from Earth. That's 44 times the distance of the Moon, but it's enough for asteroids. Astronomers did not miss this opportunity and studied the block in detail with the help of a 70-meter antenna of the Goldstone Long-Range Space Communications Complex. The researchers were able to determine the orbit of Apophis very precisely. The new data shows that the rocky visitor will not reach Earth in 2068, as previously thought. It will happily swap with our planet. However, some astronomers believe it is too early to dismiss the threat from Apophis. In 2029, he will approach the Earth at a distance of 32,000 kilometers. That is, the asteroid will be closer than geostationary satellites and will be visible to the naked eye. But who can guarantee that the trajectory of a small apophysis will not be affected by any force? Astronomers believe that the pressure of sunlight could destroy everything, and the asteroid would still collide with Earth. At the same time, from the depths of the galaxy, to us can come interstellar stone travelers, but they rarely visit our region. In recent years, only 2 guests have been noted among the stars: Comet Oumuamua in 2017 and Comet Borisov in 2019. They seem to be very rare in the solar system. In fact, stony strangers appear outside thousands of people. According to a new study by U.S. scientists, They are slowing down the Wirth cloud, which has been much more active than expected. It's trillions of icy comets in the outer reaches of our star system. It is 50,000 to 100,000 light-years away from the Sun. The star's gravity is strong enough to hold the Wirth cloud in its orbit. When another star approaches the Sun, some of the material of this halo is partially ejected into the interior of the planetary system. They then become long-period comets and interstellar objects mostly ejected into space. Most importantly, none of them have fallen to Earth. At least so far, no traces of aliens have been found. Astronomers know how to distinguish themselves from extraterrestrials. Distant asteroids have hyperbolic orbits. This means they go beyond the Sun into interstellar space and never return. In contrast, dense cloudy objects have a closed orbital trajectory. These rocks can travel to the farthest regions of space, but are gravitationally bound to the Sun. But the world of asteroids is not only diverse and unpredictable. Earth is threatened by more sophisticated rock enemies. Space travelers shouldn't look for them in certain regions of the Milky Way. Unlike interstellar visitors, they can only hide in our corner. These celestial blocks are skillfully camouflaged in sunlight. Each of them has a diameter of more than 50 meters and can penetrate the Earth's atmosphere and cause unexpected damage. This is what happened with the asteroid Chelyabinsk, which we have already met. It is considered the largest natural space object that entered the Earth's atmosphere in the last 100 years. But astronomers didn't see it coming. Coming from the direction of the Sun, it disappeared into the planet's blind spot. But is it true that modern observatories can't see such asteroids at all? The problem is that space telescopes look at the night side of the planet. This helps protect the devices from sunlight and radiation damage. Ground-based telescopes face even greater limitations. Before the Sun leaves the horizon, there is a short window of opportunity to find asteroids hidden in the starlight. Astronomers have less than 30 minutes to survey the desired patch of sky. Then the star dips below the horizon and the asteroids disappear from view altogether. During this short period of time, scientists need to observe the Earth's atmosphere, which causes light to glow and scatter from distant objects. Gases in the atmosphere also absorb many wavelengths of infrared light. This method would not be effective for finding small, dark, fast-moving rockets, but we can see them slowly. In 2022, astronomers discovered a killer planet hidden behind the Sun. It's AR7 2002, a 1.5-kilometer-wide beast with a strange orbit. It created a large celestial rock invisible to telescopes. Scientists have determined that 2022 AR7 is currently safe for use. Over time, its orbit will change as it gets closer to Earth. However, if there is a collision with them, it will happen thousands of years from now. Astronomers are close to detecting several more near-Earth asteroids in the glow of the Sun. But this is still very few, because there could be hundreds of thousands hiding from us in the sunlight. To search for such asteroids more effectively, NASA decided to go into space. In 2009, the Infrared Survey Telescope, VI-ICE, was launched into orbit. This instrument is used, among other things, to study asteroids and comets whose trajectories are close to Earth. For this purpose, the temperature of the observatory's detector must be very low. The infrared telescope will be able to make clear images and see very faint objects. WICE is cooled by liquid hydrogen. It ended in 2010, and the telescope began the warm part of the mission called NEOWISE. It detects large and dark objects in near-Earth space, complementing data from telescopes in the bright field. But finding a potential adversary isn't enough. You need to properly prepare for an attack and quickly call it off if necessary. Researchers from different countries have been studying this problem for decades. They offer effective and sometimes simple designs of barrier structures. What if you take an ordinary space brush and draw a dangerous asteroid? You must be wondering how that would help prevent disaster. To find out, scientists want to use the asteroid Bennu to demonstrate the effectiveness of their project. A specially designed drone will be sent to it. The craft will be programmed to paint half of the space rock in a bright color. It is recommended to use titanium dioxide, which is particularly resistant, as a paint. The white color will change the asteroid's thermal properties and begin to reflect more solar particles back into space. As a result, Bennu will move into a different orbit. Scientists will try to make it as far away from Earth as possible. We could organize a big sailing regatta on the asteroid. I'd like it to be farther away from us. Researchers suggest attaching a solar sail to the asteroid and using the star's radiation energy to adjust its orbit. However, you would probably need two sails. The larger, parabolic one will always face the sun. It will direct the reflected light from the star to the smaller sail, which is equipped with an engine. This would become the power source for measuring the rocket's trajectory. NASA believed that relatively small sails would be enough to lift Apophis out of orbit. They would be made of carbon fiber, plastic, or aluminum-coated PET film. These products will be delivered to the asteroid, and a small probe will be placed there. The same Apophis appears in another development, perhaps unusual but too simple to realize. NASA proposes to chase the asteroid with the help of mirror bees. To realize the project, the space agency wants to use very small areas equipped with mirrors. They can orbit around a dangerous asteroid, using their mirrors to direct sunlight to a small area of the celestial body. The sparks melt rock and metal, producing superheated gases and waste. These geysers would serve as jet engines to adjust the asteroid's orbit. For their part, physicists at the University of California don't think it's necessary to keep asteroids at a distance. Their orbit can be changed with a giant orbital laser beam. No, Star Wars isn't big enough to incinerate asteroids like the Death Star. We don't have that technology yet. But mankind is quite capable of building 1 gigawatt lasers. Scientists estimate that the device can burn up to 100 meters of the required surface area of a small asteroid. This is enough to shift the orbit of the Big Sky Stone by about 2 Earth radii and avoid a collision with our planet. But scientists still consider the kinetic impact the most effective and realize this option. In September 2022, the entire world watched in real time 11 million miles from Earth. NASA's refrigerator-sized DART spacecraft flew close to the asteroid Didymus. But the study was interested in the relatively small satellite of this celestial body. Dimorphic, about 170 meters in diameter. The purpose of sending a sonic was to collide with Dimorph and change its orbit to Didymus. The DART flew into the sky at about 22,500 kilometers per hour. The impact released energy equivalent to the explosion of 5 tons of TNT, which caused the asteroid's material to be ejected into space. This process created jet propulsion and imparted additional momentum to the Dimorph. In addition, without studying the composition and structure of the celestial rock in advance, to accurately calculate the necessary force of impact is impossible. NASA decided to take a risk, and it worked. The period of circulation of the satellite around Didymus decreased by 32 minutes, and its speed decreased by 2.7 millimeters per second. That was enough to change the orbit of the small Dimorph. But what if the asteroid turns out to be much more massive or late? Then it would be necessary to change the orbit quickly and radically, for example, with nuclear weapons. But we must remember that a nuclear explosion in space is not at all like an atmosphere. there's probably not enough gas in the space around the asteroid to create a powerful blast wave. The device only affects the unit with light, X-rays, and a stream of neutrons. All three impactors will heat the surface of the asteroid and vaporize it at great depths. This process works like a rocket engine. The vaporized rock will push the celestial body in the opposite direction of the explosion. At the same time, there was a proposal to use another asteroid as an effector instead of a spaceship. According to calculations of the authors of the idea, such billiards will be almost 2 orders of magnitude more effective. They also want to use an electromagnetic catapult to change the orbit of the asteroid. Laser gun, shockwave emitter, tractor. All methods have advantages and disadvantages and require additional cleanup. However, it is clear that the fight against aggressive asteroids is intensifying, and we will be watching it closely. But our space travels don't end there. Let's move away from the image of evil and aggressive celestial rocks and look at asteroids from a different perspective. They can be unique, infinite, and full of amazing cosmic mysteries. Asteroids include giants over 500 kilometers in diameter, such as Vesta, as well as smaller ones, such as 2015 TS-25, measuring only 2 meters. Some are spherical in shape, but these are the exception. Most asteroids look like regular, irregularly shaped rocks. Sometimes they look like crater-shaped peepholes or rough peas on a potato. And the rare ones can be compared to large hamburgers, as they are rolled together with 1 or 2 garnishes. It's also generally accepted that all asteroids are coal black and invisible in the darkness of space. In fact, 75% of them are. But the rest can please space travelers with a spectacular fire-in-the-sky show, like stars. Vesta is considered the brightest asteroid. It is the only one that is almost always visible from Earth. It is also one of the largest celestial bodies in the main asteroid belt, located between the orbits of Mars and Jupiter. The diameter of the giant is 525 kilometers. The temperature on the asteroid varies depending on the season, from minus 190 degrees in winter to minus 3 degrees in summer. But Vesta wasn't always this steep. At the beginning of its formation, there was a red-hot iron core that partially melted the rocky mantle. Over time, the core cooled, and a large amount of minerals formed in the mantle. Several large-scale collisions occurred on the surface of Vesta, leaving hundreds of kilometers of craters. This is confirmed by meteorites found on Earth that left the asteroid after violent collisions. Comet wars have created a strange phenomenon in Vesta. Many interesting things await space travelers in its icy world. The most noticeable feature on the asteroid's surface is Rio Silvia. According to various estimates, the diameter of the crater is from 475 to 500 kilometers. It is a bottomless pit that is 20 to 25 kilometers deep in the asteroid. Rio Silvia is considered one of the deepest craters in the solar system. It is surrounded by real mountains, the highest of which is twice as high as Mount Everest. Also on the equator of the asteroid can be seen a whole system of amazing trenches. Astrophysicists believe that this is also the result of the collision of Vesta with other celestial bodies. The longest trench, Devalia, is 465 kilometers long and surrounds the asteroid. It goes to a depth of 5 kilometers. The 60-kilometer-long main belt asteroid, discovered by astronomers in 1885, is also beautiful. Scientists often refer to it as the Emerald Comet. We can't actually find any gemstones there. The asteroid is covered in the light green mineral olivine. Because it is so far from Earth, the colors are not blurred, and we can only see Asperina as a white dot in the sky. Olivine is a mineral formed from silicates and iron at a temperature of 1,000 degrees Celsius. It's a mineral space. Astrophysicists find it in many celestial bodies. For example, olivine is a major component of the lunar regolith, but Psyche 16 is probably the real Klondike. It's located in the solar system's asteroid belt between Mars and Jupiter. It's a large metal block with a radius of 113 kilometers. What treasures does it hide? Astrophysicists recognize that Psyche is rich in gold and even platinum, enough to make every person on our planet a millionaire. But most importantly, Psyche has simple metals, iron and nickel. They are invaluable to researchers. Scientists hypothesize that the Psyche has an iron core and a rocky mantle. As a result of a unique ferrovolcanic eruption, iron falls to the surface of the asteroid, covering it with a metallic crust. The hypothesis is that Psyche is the bare iron core of a planetary body, whose rocky crust and mantle were destroyed by an ancient impact. Psyche's spaceship should do the right thing here. It was launched on October 13, 2023, and will reach its destination in 4 years. If the second theory is confirmed, researchers will be able to study the planet's core for the first time. This will, among other things, allow us to understand how many metals are present in the Earth's core. Asteroids in general can reveal many pages of our planet's history. In 2018, scientists studied data from NASA's Dawn spacecraft, which returned from a major mission to the solar system's asteroid belt. They found that the planet world of Ceres is filled with complex organic matter and ice. It may also have active volcanoes spewing salt. The organic molecules on Ceres were left in a crater about 50 kilometers wide by the impact of a large asteroid. Scientists are now trying to pinpoint the origin of these molecules. One theory is that carbon-rich steroids brought organic matter to the planet. The molecules may continue to grow in an underground ocean, believed to be hidden inside Ceres. And perhaps space divers will find simple life forms in Ceres's waters. In the same way, asteroids can bring organic molecules to Earth. Then they could be called our ancestors. It seems unrealistic, but scientists confirm this version. In October, NASA announced the first results of the study of samples taken from the asteroid Bennu. The material turned out to be saturated with water and rich in carbon, from which all life on our planet originated. According to scientists from the University of Arizona, this discovery is a direct confirmation of the hypothesis that life was brought to Earth from space. Researchers continue to study the material that makes up Bennu and hope for new discoveries. In particular, they want to find more complex organic compounds in the samples that could support an asteroidal version of life on Earth. Recently, researchers at the University of Tübingen in Germany isolated selenium from rocks in Earth's mantle, meteorites, and asteroids in the outer solar system. But Earth's mantle is not supposed to contain selenium. It is attracted to iron, and in the early days of our planet's existence, this material sank into the iron-rich core. Scientists say that space rocks from the far reaches of the solar system brought volatile substances, including selenium, which the Earth needs to build organic molecules. Only in this way, once the core is formed, can it enter the Earth's mantle. Also, asteroids probably brought us large amounts of water and carbon, from which all life originated. According to one hypothesis, about 60% of water also comes from asteroids. German scientists believe this is the only way our oceans can survive. The celestial clumps that gave it all to Earth are now far away from us. They are located outside the solar system, beyond the asteroid belt in the orbits of Jupiter, Saturn, Uranus, and Neptune. Who knows? Maybe in the distant future, they will in some way save the life they created. This time, asteroids will serve as a kind of Noah's Ark for humanity. In 1 billion years, the Sun will be out of control. turning our world into a lump of coal. Humans will have to move away from the star to avoid death, and probably along with the planet. For this purpose, according to some scientists, can be used one of the 100-kilometer asteroids traveling between the Sun and Jupiter. In 1,000,000 years, water from the sky would carry our planet to a safer place 75 million miles from the Sun than it is now. Sure, the project seems fantastic today, but in the future, it will become a reality. And one day, the Good Samaritan rock will give us a second life outside the solar system. In the meantime, we mustn't let our guard down. We are threatened by some asteroids. Unlike the dinosaurs, we must stop the attack. To do this, scientists are preparing new missions to study the composition, orbits, behavior, and capabilities of asteroids. In 2024, the European Union plans to launch a small artificial satellite called CubeSat to study a small, roughly 100-meter-long asteroid. The exact candidate for the mission is not yet known. In the same year, a Japanese spacecraft will fly into space. Its route is known. Umbrellas will be sent to the asteroid Phaeton. At the same time, NASA has unveiled its 10-year strategy, aimed at protecting Earth from collisions with asteroids and comets. The plan includes 6 major areas, such as improvements to NEO Suver, a camera for observing near-Earth objects. In addition, technology will continue to be developed to destroy dangerous rockets, like the DART mission. Most Earthlings ignore the asteroid threat. Of course, everyone does in different ways,